Thank you for the introduction, and also I would like to express that it is an honor for me to be here. It's my first time that I'm in South Africa, and obviously then also the first time that I could speak in an academic context in South Africa. So a sincere thank you from me at first to the organizers, but also to the audience. I would like to present a study which I did together with Eva Thomm, which she had been in my lab, and when she had been there, we had done that together. And that is what I would like to talk about. First of all, I would very shortly run through the arguments why disciplinary structures are, in my view, inevitable for the production of scientific knowledge, why we need disciplinary structures. This is, I think, important because there's always the call for that it is necessary to have interdisciplinarity and multidisciplinary perspectives. I think at first we need disciplinary structures. And then I would like to present a study about people's capabilities for understanding disciplinary structures. I'm an education psychologist, and therefore I'm always interested in what people already know in order to build on that for what we have to teach them. So let me start with a very short definition. What is a discipline, which I found in Wikipedia. Wikipedia is very good for that. As you see here, any comparatively self-contained and isolated domain of human experience which possesses, and that's important for what I'm going to talk about, its own community of experts. So in the core is that disciplines are structures for organizing and dividing knowledge. And as we know them today, I think, as far as I understood, the very concept of disciplines as we know them today, for example, physics, chemistry, but also literary studies, emerged in Germany approximately in the 19th centuries. And what is also important for the following is that disciplines have a dual character. They are both cognitive and social organizational units, and I will come back to that dual character later. So a few characteristics of disciplines, and I have put images of two book covers because this is the background, or one could say the justification, their arguments put forward there. And also the third book I forgot, that is by Oreskes, Why Trust Science. So this is the background, the so-called social epistemology, which is a philosophical approach, is the background of my arguments. So what are disciplines? Disciplines are cognitive units. They are defined by its subjects or their field of research, but they also actively shape what constitutes that subject or field. For example, biology, the science of life, yet it also defines what life means. So there you have also this kind of duality. Then disciplines are organizational and social units, communities of scientists who identify as, for instance, biologists. And these communities organize themselves in schools, institutions, departments, but also professional associations. Sometimes there are tensions between the professional association and the schools. But also they define themselves by structured curricula and also by career pathways and correspondence, again, to professional fields. These are, so to say, the organizational aspects of what makes up a discipline. And what are features of disciplines? By means of a set of accepted research methods and by means of a specialized terminology, they organize knowledge, identify what is already known, and also highlight unanswered questions, and of course they pass knowledge on through teaching. And this means they provide a kind of discussion frame, so to say, a kind of conceptual discussion frame for just these purposes, like organizing knowledge, identifying what is already known, and so on. What are above that, the functions and limitations of disciplines? First of all, the preservation and continuation of knowledge. That means maintaining existing valid knowledge while simultaneously adapting it to new research questions. And disciplines do that more or less successful, of course. This is not always a success story, but this is in principle their cognitive or epistemic function. Therefore, disciplines continuously evolve. For example, genetics has gained prominence in biology and subatomic particle physics in physics and so on. Disciplines provide a focused perspective allowing for depth, but they also, of course, and obviously narrow the scope. When evolutionary changes are insufficient, disciplines may transcend their boundaries, giving rise to new disciplines. Examples are these recently emerging fields, or nowadays emerging fields like data mining or cybersecurity, which at least in parts of the communities are nowadays taken as own or understood as own disciplines. Additionally, interdisciplinary and transdisciplinary collaborations emerge from these shortcomings of disciplinaries. Yet, interdisciplinarity and multidisciplinarity does not make disciplinary structures obsolete. Rather, they rely on the existence of well-defined disciplines. That is very important to have these tensions, so to say, in mind. Why disciplinary structures matter for communication, for communicating discovery science? I think understanding disciplines is crucial for science communication for three main reasons. First, obviously, they are relevant for science communication because disciplines make up science. And if we want to talk about science, we have to talk about disciplines. In that sense, it is trivial, but it is true. This is my first point. The second point is, and this is less trivial, but even more important, disciplines provide roadmaps for navigating the landscape of knowledge. Providing especially lay people or citizens with roadmaps of knowledge to help them navigate areas of interest or identify the appropriate experts for specific questions is especially of high importance nowadays when people are in principle in a situation where they can get any information about any of the issues they are interested in the internet. Therefore, such roadmaps are very important. And they are especially important for discovery science in order to avoid this focus, to avoid what has been discussed also this morning, too immediate focus on problem solving and transfer as main arguments. These are not only main arguments put forward by those who had been mentioned here, but this is also part of the, so to say, everyday idea people have about science, that the main effect of science, as we also have seen from these data, should be transfer and application. And in order to counter this widespread belief, it is necessary to emphasize the role of disciplines. And science communication could rely, and this is my second point, on people's intuitions about disciplinary knowledge structures, and I will come back to that now. And finally, and will then afterwards be my last remark, disciplines provide frameworks for establishing and knowing about, revisioning the consensus among experts, and I will come back to that. But now let me come to this, to the empirical data showing that people have a kind of intuitive judgment and capabilities to intuitively judge whose expertise might be pertinent for a certain topic, even if we ourselves have no or only little knowledge in the field of that topic. There's an American education psychologist by the name Frank Kyle, the Yale University, who has shown that for children. And these studies, they inspired us, Thomm and me, to try to show that also for adults. And the point is, as you will see now, that the people's capabilities to assess the pertinence of experts for questions exist already, even then if they have any understanding about the topics where they are looking the experts for. So our question was, do individuals have accurate notions about who possesses expertise of a certain topic, regardless of their own prior knowledge, which is their very reason of searching knowledge. online. I mean, they don't have the knowledge, therefore they are searching. And the question is, do they, while they have no knowledge about that specific topic, nevertheless have a kind of intuition which expert to ask? This was the basic idea of the study. This is what we did. We provided participants with 4 short texts on science topics said to be retrieved from the internet and indicated to what extent, and then we asked them to indicate to what extent experts of different disciplines, biology, chemistry, environmental science, might have contributed to the text of phenomena of physics and climate change. So this is how it looked like. We took from Nature abstracts on relatively complicated topics. But of course, as these abstracts, they are more or less understandable. And then we had 2 texts on climate change topics and 2 on physics topics. And then we asked the subjects to estimate, to rate the degree to which the respective experts of that list might have contributed to the online text, because there were no authors in the online text. They simply read the text, and so they had to, in a sense, to impact to which degree is this a physics issue, a biology issue, to which degree is this a chemistry issue. This is a kind of our approach to measure intuitive ideas about disciplinary relatedness. And then we wanted to compare that with a kind of objective measure, because we want to know, are our subject doing that well or not well? And therefore, we developed a kind of bibliometric method to measure the real relatedness of these papers to different disciplines. I have not time enough to go into how we did that. It is as I said, it's a bibliometric procedure, and then we calculated product moment correlations, measuring the fit between the subjective and the objective bibliometric measure of pertinence, exploring the accuracy of individuals' pertinence judgments. And then this requires a lot of statistical analysis and refinement. And what we finally found, and this is the important, is relatively high and clearly statistically significant positive correlations between these objective measurements of disciplinary relatedness and the subjective judgments. So we can take it for granted, and as a starting point for talking about disciplinary structures, that people have well-functioning intuitive ideas about disciplinary structures. And this helps to talk about the nature of disciplines in science communication and discovery science, and why is this so necessary? And I would like to come back to my point, which I made in the beginning. I think it is so necessary to talk about disciplinary structure and then to rely on these people's intuitions about that, because the concept of science in generally is a complementary concept, covering always 2 aspects. On the one hand, it is a set of distinguished knowledge referring to a piece of reality. But on the other hand, science is always a social endeavor. It rests on agreement among experts. The scientific consensus is a way of establishing valid knowledge. And this duality I try to exemplify by these 2 pictures. What do you need to find the Higgs boson? This is my point. You need this huge machine producing the data, and you also need a lot of coffee, because the decision if these data really means is this a Higgs boson or not are done by groups of researchers, and what do groups of researchers need when coming to such an idea? Of course, coffee. So you need this machine and you need coffee to make a scientific finding, and this is very important to emphasize, because this is totally in stark in contrast to an everyday idea which we have about knowledge. It does not make sense to make it dependent. Everyday question, is this wrong or false, from a consensus among people. you simply can look around out, is it true or not true that the sun is shining? But when it comes to science, you always have these double, you always need a machine and you always need coffee to come up to know what is valid and what is not valid. So, to put it in other words, scientific knowledge is data-based and simultaneously dependent from a consensus within the scientific community. This is my last sheet. The concept of a scientific discipline is well suited for explaining this complementary nature of science and hence for explaining why we can take a piece of knowledge as, of course, provisionally, but nevertheless valid knowledge. And addressing this complementary is essential because this dual nature of science is a common target for science denial. Science denialists typically exploit the social organizational aspect, the social consensus aspect, claiming that scientists are merely a group agreeing arbitrarily on a world view. And I think, or I would argue, the concept of discipline is a key for talking with citizens about this complementarity as well as about the history of science and thereby also about the continuous changes and transformations of our scientific understanding of the world. And as others have said, as our studies has shown that there are people's intuitions on pertinence. They show that it's not to discuss about these topics, which sound in the first second you might say, oh well, this is very elaborated epistemologically theory stuff, but this is not the case. You can talk about these things because you can rely on people's intuitions about disciplinary structures and about knowledge structures. In a sense, I also promised games and what to do. One possible what to do to get that this message across, and I think it would be nice to do quizzes. And you all know this quiz of who wants to become a millionaire, and you also know there's this element in you can use a telephone joker. You can call someone, and I always ask myself, they don't know what these concepts mean. How do they know who they will give a call? They have an expert in science and an expert in literature at home, but how do they make the decision whom to call? And I think that is exactly the situation I was talking about. And as these people are able to get a lot of money, I think we can be optimistic that people understand disciplinary structures. Thank you for your attention.